Yeah, morning guys. Okay, let's start. So last session we mainly focused on the system design, right? How we are architecting, what are the things we need, how the database is going to be, everything we go through, right? So from today onwards, this is the things going to be the cloud. So can anyone tell what is the cloud, what is on-premises, what is the difference, how it is different from that? Any idea? Sir, I already don't have any idea about the system design. You are asking a new thing. What is meant by cloud? What is cloud? Hmm?
Services which are provided over internet.
Services which are provided over the internet. Too nice. Okay, any other points? What are the providers was there? Cloud providers.
AWS,
Hmm.
Google Cloud,
Microsoft
Microsoft Azure.
So these are the major Google providers. Apart from the some other providers was there, but these are the top 3 level guys. Okay, fine. So here, what is the major advantage I'm going to get it from the cloud? If I'm going to get from some services over the internet, right? That means the remote services I can able to get from the internet via internet. Okay. What is the advantage I'm going to get it from there? Instead of using my local machine, if I want to deploy my application, I can deploy my application itself, right? I can publish this one to over the internet. Anyone can access that. That is not a big deal. That we can do that. Then what is the reason we are choosing the cloud over the on-premises? So on-premises is nothing but that is our local system. But so many guys are moving cloud to on-premises. Why? Because some security and those many things they are planning. That's why they are switching, and some other reasons also there. But apart from that, any other major advantage I'm going to get it from that if I'm using the cloud provider services.
Data security.
Data? Okay. Any other points? Hmm?
Back.
Local also you can take it the back.
If we have the huge amount of data,
Hmm.
sometimes we are not able to handle.
Why we can't able to? If you buy the hardware, you can easily handle it. You can get the some TP in a just smaller, this much level chip. You can get it for the TP. You can store the TP level data. What are the data we are storing in the database in Postgres? What do you think? How much byte it going to take? In my entire production database, it won't take that more than 100 MB. Within 100 MB. If I'm using the millions user, maybe it will crash the GP, maximum GP. It won't crash more than that. If you are using Postgres, then backup is not a big deal. I can just complete it within 100 rupees. Below that also I can do it because memory card was lower than that. Backups also one of the part. Okay, but I can do in the on-premises also. Any other advantages from the cloud providers? Any ideas? No. It's nothing but like a first thing is that we can able to get the services from over the internet, right? This is the first thing. Next thing is that like platform as actually there is a three things. If you are went to the cloud, they will tell the three terms. Okay, one is the software as a services, that is a SaaS. Another one is the infrastructure as a services. Okay, then platform as a service also there. Like if you take an example for a SaaS in the sense like a YouTube is a SaaS. Why? Because entire thing they are giving as a software. They are providing a service. If you are taking platform as a services, you can get it from the cloud. Like I want only the platform. That means so let's get the things from the infrastructure. After that, I will explain the platform. Okay. So we'll get it from the infrastructure. What is mean by infrastructure? What are the things I need if you want to build any infra? I I want to deploy my application. What are the prerequisites I need? First of all, I need a machine. That machine definitely contains the OS. If it is taking the OS, you have to define the RAM and storage, everything, right? So like that. If you want to do that, if you want to buy the things in the hardware system, you have to boot yourself. Everything we have to do, but we have to pay some amount. But here it's a one-time payment, right? But it will be definitely, if you are buying the hardware directly, it will be definitely more costlier than the cloud service providing. If you are using cloud providers, the same thing you can get it from there as well. You can get the system, you can get the how many RAM you want, how many GPU you want, how many CPU you want, everything you can get it from there. But that is like a rental. You can take as a rental monthly, the bill generate if you can pay the bill. That is a simple flow. So no need to overhead in our end. I have to manage the server here. I have to put one person. He will take care of that. If power gone, what going to happen? If any crashes on that particular hardware, what will going to happen? We don't have that particular team for that, right? But there, those guys maintaining everything. Final output, what they will give a one machine. You can use that machine via internet. Simple. So this is the major advantages if you are using the cloud providers. And the data security, data backup. So if you are storing in your local hardware or the only one machine, maybe your data will be stored that only one machine. If any possible way, if your system crashed, if any glitch happened, most of the time it won't. If it is any rare case, it is because that is a machine. We don't guarantee when it is going to fail, right? So if it is failed, your data was gone, we can't do nothing. If you are backed also in a separate device apart from that hardware, you can't do nothing with that. But in the cloud, they will take a duplicate data of the multiple servers, not only one server. If one server crashed from there, and they will give the services from the another server. Let's take example. If they take any cloud provider like a Google, if you are taking, you have to choose the region. Whenever if you are taking the any mission, so that is called as, here we are taking this mission, right? That this is called as a VM. So VM is nothing but virtual machine. You can take a rental virtual machine. If the bill will be generated while you are choosing itself, they will tell like this is the cost for this RAM. If you are using 2 GPU, this is the cost. If you are using only 1 CPU, this is the cost. Like that, they will mention how much RAM you want. Everything you can take it from there. So these are the major advantages. How you are maintaining everything. If your team was too bigger, you don't want to get, because that time if you are taking the rental, that will be too costly. So that time if you want to move, you can move to the on-premises. That is up to us. If you want to take the overhead from our end only, I will take care of everything. That is up to us. How we are going to manage that one. But that the things will be totally different. Okay. So and one more thing, whenever if you are taking the any VM for rental, choose the region nearby to you. If you are taking your application mainly if you are deployed in the India, okay. Let assume you are going to deploy your application only for India region. While you are selecting, select the India regions, not outside that. Maybe Asia, Kolkata will be there one of the region. You can select that region, which one near to you. If you are deployed your application in the server in the US, maybe it will be some delay will be there, maybe milliseconds, 1 or 2 milliseconds, it won't be more than that. Maximum 10 milliseconds, but it will have some latency. Why? Because your request have to process in the US, then you will get the response. Few latency will be there. Then we have some concept called as carbon fingerprint and those things as well. Like how much time carbon fingerprint is nothing but if your request was processing, right, how much time it was taken. That is like how many hardwares used for that. So those things is called as the carbon fingerprint. Okay, this is a true depth that is not required. So these are the top level architecture about the cloud. So do you guys have any doubts in the cloud? This is the top level things. Okay. So what kind of services, what are the types they are providing, everything we'll see one by one. Okay. So here like this is the module 4, like a compute and runtime models. Yeah, this thing we never see. So compute model is nothing but what is meant by compute simply? What is meant by compute? What is mean by compute? What is compute? What is computation? If anything processing the any request or any particular block of statement, that is we can tell as the computation, right? Okay. So computation module is nothing but if any one of the services or any one component processing your request, that is called as a compute. Okay. So here we have few compute models. So what are those actually? So one is the VM instance. Okay. So VM or else instance. So this is nothing but it's just a machine. Like how I am having the laptop here. So VM or instance in the sense that is one of the machine. That's it. Okay. Apart from that, nothing else. In that machine, what other things will be there? OS will be there. Some other things will be there. But few things I have to do in the custom way. Okay. This is for the one compute model. First compute model. Compute is nothing but if you want to process any set of requests, any instruction you want to process, you want to get some output, you have to do the work. That proper set of work is called so called for the computation, right? If you want to do the computation, we need a hardware because it has to run in the computer, right? So we need a hardware. So for that, what are the models we have? Okay. So first two models is going to be VM and instance. Okay. VM is nothing but virtual machine. So what are the machine I have here is real. There is called as a virtual machine because we can't see that machine. We can able to use that machine, but we can't see. Okay. So next one is the container and pod. Container is nothing but under pod. So these things is come under the Docker and the Kubernetes. Okay. So this also one of the part like container and pod is also one of the services like one of the computation. Okay, that also can able to process your set of instruction, some set of processing it can do. It can able to process the request. Okay. Then serverless. Serverless is nothing but like a you don't have any specific VM or for that. Like if you have only website for deploying your website, you don't need a server. You can deploy as a serverless services. That means the VM won't be there, the storage won't be there. This serverless is the more efficient way. If you have some most of the static website or few dynamic or not fully dynamic, few things if you are doing, you can deploy in the serverless services. Serverless service, what it will do, how much you are using, you have to pay for that one only. You don't have to pay whole thing. Like if I'm going to set up my own PC, so if I'm taking 16 GB, 32 GB RAM, I have to pay the entire amount. But my main use going to be 1 or 2 GB, maximum 4 GB, 5 GB I am using. System will take some 5 GB. This is the maximum usage, right? Then why I am taking that much GB? Here it won't be like that. How much you are using, you have to pay for that. That's it. Okay. So here we have some pros and cons also there. Okay. Next one is the how the architecture going to be. So here we already knows this. Okay. So there is three types. We mainly discuss the two things. Okay. So one is the monolithic, another one is the microservices. Can anyone tell the difference between the? So what is the major difference between the monolithic and microservices? What are the advantages? Well, I have to choose which one. Simple.
Monolithic means when we have a single service or all features are in single deployment. But in microservices, we divide the functions or the services into chunks and deploy it according to that.
Yeah, so what is the major advantage I'm going to get it from that? If I'm moving monolithic to microservices. What is advantage?
We can check the functionality or each service. If it is categorized, then we can efficiently work on a single service. And if any errors caught in that, it will be easy to handle.
Okay. Okay, that is good enough. But so while giving the things to interviewer, don't give it like that. So giving such a way. So don't tell always is make a easy those things because those keywords kill your things. That means you are going to do some kind of blabbering like that, they will think. Okay, so don't use few keywords. That is, my first keyword is going to be easy. So you can tell such a way like that. So you broke into the multiple chunks. That means what is the benefit you are going to get that if it is one chunk crossed, another chunk won't affect. The same thing you applied here also. Only services, if anyway if it is crashed, another service won't affect. That means it got isolated. So here I have the keyword isolate, right? So these kind of keywords only going to give the weightage for you, not the easy things. Here also easy. If it is isolated, for maintaining the things will more. So that is the scalability, maintainability. Use these kind of words. That is more aggressive to compare with the other words. Okay. So further, what are the things you guys know? So that is more than enough. But express in such a way, so too important. Okay. So this is the absolute correct things. So modular monolithic is nothing but like is a middle of that. Like if you want to manage, don't want to go to the microservices. Maybe in future, if I want to go there, so that time you can set some boundaries, like how you can do that in single project itself. How I am managing the project structure. Like that, you can categorize the services as a different folders. You can do that. You can manage that. Instead of I managing all the things in the only one repository, one folder only. But inside that folder, if you are managing the proper hierarchy for each services, that is like called as a modular monolith. That means I modularized something. So this is also fine. For scalable, if you want to break into the microservices also, you can do that. Just take that part, create as a new service. That you can do that. Okay. So on the major issue will where it is when it will happen in the microservices, communication between the services. Okay. So now I am giving you one more thing. So we have the things. If you want to communicate between the services, what are the technology you are going to use? How can we communicate between the two services? Protocols. Protocols is one of the set in the request. What are the way we have? If you want to communicate between the services. Okay, if you want to communicate between the client and the server, what is the way? API. The same way available there is. If you want to make the communication between the two services, you can use in the API. Here, after that API only, which protocol are you using while calling that API? Protocol is one of the method how you are calling that API. So it could be gRPC or it could be REST API. Which one will give more benefit? Okay. Fine. So orchestrate safely. So do you guys have any exact understanding or clear idea about orchestrate mean? No. Any idea about what is meant by orchestrate? Okay. So if I want to give any instruction to you guys, what are the way I have to communicate to you? I want to pass the information to all the guys. How can I do? What are the ways I have? Like I want to tell after the class was completed, I went home. Okay, and that I have to tell tomorrow there is no classes. How can I tell? Telegram group. So that means I orchestrate your all the peoples in that one particular group. If I'm giving only things, you guys all the guys will receive the things. So that is called orchestrate. Orchestrate is nothing but bringing the all guys into particular place, how we are managing these services. Let's come to our microservices. Microservices orchestrate is nothing but you have the services running independently, isolated way, right? But you have to manage and keep an eye on the each services when it will broke. I have to fix it, right? For monitoring when which service have to kill and retry. Like when the service no longer, I have to remove that. So that is called as orchestrate. So what are the things we are maintaining in one particular place, who is orchestrating. We have the multiple orchestrate tools was there, Apache Airflow. If you are taking like if you want to do the job some scheduled timing, like each night 2 o'clock, every time you have to 2 o'clock, you have to take the backup file entire database. That is one of the work. How can I do that? There is a two ways. One, I can manually trigger at the 2 o'clock, or else I have to automate. How can I automate? One way is the cron jobs. So I hope you guys know that what is meant by cron jobs. Cron jobs is nothing but you can schedule the job that will automatically trigger that particular time. That is the one way. What is the next way? Next way you can use some other tools. So like Apache Airflow. Apache Airflow is one of the orchestrated tool that is open source actually. What those guys will do, you can able to set all the things. You have to call after 2 hours. Every 2 hours you have to call this method. Like that you can able to do that. So where I did all the things using Apache Airflow tool. So that is so called orchestrate. How you are managing all the services. What are the things you want to do. That is so called for orchestrate. Okay. So here is nothing but they are discussing some things about Kubernetes. So Kubernetes is nothing but, so you guys know like Docker and everything, right? So any doubt in that? Clear? What is the purpose of Docker? What are the things in the Docker? So can anyone tell what are the major topics in the Docker? Where it will start? Where it will end?
Image creation, containerization.
Image, container, next. Yeah, correct only tell. Can I create multiple containers from one image? Is it possible or not?
Yes.
Is it possible? Possible or not? Yes or no? One image, from one image can I create multiple containers? Correct. So it start from the flow. So you need a first image. So that means your base. So for creating the image, what file you need? You need a Docker file. So from that image, you have to run your container. You need a Docker compose file. So from image to containers. Inside that container, each container having some data. It has to manage the data, right? So what is that one called? That is called as a volume. Okay. So image, container, or services. Next is the volume. Any other things? Network. Networking is nothing but it's a bridge to communicate between each container. That's it. These are the four things in the Docker. Then we have one more thing is for the Docker Swarm. What Docker Swarm will do, like it's a bit advanced level, like what Kubernetes was doing, but they are not trying to compete, but it's not fully successful, I guess. Okay, I also played it sometimes, but it's not getting as much what I expect. So what Kubernetes will do, you think about your server was running. Now your server was only one server, but now user base was increased. You need another server as replication of your server. How you can do that? Manually at 2 o'clock, how can I wake and how can I do that? If it is my server got crashed, like the next 5 to 10 minutes the server was unavailable. How can I manage that? If in that server any one of the service was crashed, how can I manage it? So for that time only they introduced the Kubernetes. Okay. So Kubernetes is nothing but is orchestrate tool. So it can take care of entire orchestrate of your application from the server. Inside the server you have the services. Like let's take an example. I have a payment service. Each 10 seconds or 5 seconds the health AP was triggered. That is the way Kubernetes there it is called as a pod. Pod is nothing but that is a smaller unit of like if you are taking one services, you can deploy in the pod. Okay, so that is one smaller unit in the Kubernetes. Okay, so pod is nothing but if you are deployed one payment service in one pod. Now payment service running in the pod 1. So that means if it is a payment service crashed or not available, what it will do? It will remove or it will kill that unused services or not successful services, it will remove that. It will try to recreate the payment service again. Redeploy will be happen automatically. If this load was increased, it will redirection to the request to other places, or it will you need a duplication of another server also. It can do. Like I am talking about the machine, right? So is it possible actually manually? If I deployed anything in the one machine, can I able to deploy the same things in another machine? How much time it will going to take? My server, this one machine is not enough. But there, if you are using the Kubernetes, you can set up. So if you need another servers also, if you need another machine also, another VM you need, you can deploy. That will done by automatically. Initial setup you have to do that. Okay. There only the scaling coming to the picture. So scaling and the distribution is a major part in the application. All the application in the enterprise level application, scaling and distribution is a key. Okay. So this is the core primitives is nothing but how the deployment, how the replica set. So replica set and the deployment is nothing but how your deployed your application, how your rollback system going to work. That is the two things. Okay. Then service ingress, like this is like how you are managing your traffic for each request. That's called as a service and ingress. Next one is a config map or secret. These things is known as you want to manage the environment variables. Other things we are managing data in local, right? The same thing you want to manage in the Kubernetes. There it's called as a config map. That's it. Key and value pass is a map. Config is a secret things. That's it. Next one is a stateful set. What is meant by stateful set? So these are a bit new terms. Stateful set is nothing but like is can able to identification of your application loads, workloads. Simple. So as of now, this is enough. A bit depth level I will explain for the Kubernetes. But cloud engineering, you guys know about the flow, how the system was working in the cloud. How the system was working in my local, like if I'm applying, it was running on particular port, right? After that, I did the containerized way. I took a Docker. After that, how you can deploy via Docker. The same thing I have to do with the server. So that time, what I have to do? So I have to build the image, have to access the image from the server. Okay, so that time if you are using GCP, so you can put your Docker in. That I don't need my entire code base. I can because I already have the image. From that image I can run my application, right? So what I will do that I have the one concept or one particular things is called as a artifact registry. Artifact registry is nothing but like a GCP it's a artifact registry. If we are going like AWS, that is called as a ECR. Okay, Elastic Compute Registry. Okay, so if you are going to ECR, you can put all the images. What are the images you are building? Going to deploy further, you can put the images there. From that images you can deploy. It could be the stateless services or a full stateful service. Stateful services mean you are deploying the VMs, virtual machines. Okay. So deploying strategies, simulator, like this is kind of some graph was built. Like you can check like how much traffic percentage happened. So overall how much input rate was increased, how much error rate, how much P95 is nothing but P95 is one of the key part for the bug mentioning. Is a crucial bug or is just a medium or low level bug? P95 is a high level things like that. Okay. So these are the major things for the cloud. Apart from that, in the cloud, if you are until unless if you are go through that, you won't get the chance to get the clear idea. So I suggest for GCP, you guys able to do that. So you can get the 300 credits for free. Okay, initially you have to give some card details, but it won't any amount won't be deducted. So you set some alarm or some proper reminder. Within 3 months, you have to close that. You have to close that auto pay. Or else amount will be getting around 10K or something. So before 3 months, if you are closed, there is no issue. Or before 3 months, if you are used to 300 credits, 300 credits in the sense $300. It's around roughly 30,000. Yearly 30,000. So they will give it as a free. You can use their services. You can able to create the VM and everything. You can do that. Okay. So save production rollouts. So it's nothing but now to take one example. I have a one version I deployed into my production server. But after I deployed a new version, my things got failed. So I think Firebase. For example, I'm telling. Okay. Okay, let's take it. Is it visible, right? Okay. So now I deployed one application in Firebase console. Okay, this is a multiple. This is some other platform. This is also done by Google only. Okay. So I deployed one of my front-end application in Firebase. Like I can go to the hosting. Here I can show the that the rollback. How many version? What is my current version? This is my full history. Like how who are I deployed. Okay, these are the versions I deployed. Now this is the current version running, right? So if I want to roll back to this system, okay, I want to roll back this version. What is mean by roll back? Roll back. What is roll back? Hmm? Back to previous or forward or anything. Most of them roll back is fine. Backwards only. Roll back to previous things. Okay, so that means that I deployed on new version. My new version got crashed. So what I can quick fix what I can do. My existing version definitely working. With a new feature only, my new version not working, right? I can roll back to my old version. So maybe in accidentally if I deployed any one of the version, okay, that version is not working anymore. That got crashed my entire server. What can I do? I can roll back to this previous version. So here if I click the rollback, what's going to happen? My entire production server roll back to old things. Okay. If I click to that, my version got be rolled back. My new feature won't be available. Maybe either I can use some smooth version because previous version is working smoothly. Why I have to broke that? I can fix it. I can redeploy again. That is possible. Okay. So this is the rollback system. How the here I am showing manually, but automates also you can do that. Okay. So rolling that is a rollback actually. So rolling deployment is nothing but so what I mentioned earlier is parts is right. Parts is one of the particular smaller part in that Kubernetes. So you can deploy one particular service in that. Okay. So like if I deploy one particular version, that means a version one. For payment service, I deployed a version one. But in the version one, I have some security issue. So I have some vulnerabilities. I have to mention that this is the latest version. You have to pick the latest version. So that setup will be bit complex in that part actually. So some advantages also there. I don't have zero downtime. Definitely resource will be more efficient and built into Kubernetes. So these are the pros. Cons is nothing but like both version run simultaneously. That means like my newer version also will be run, my old version also run until unless I killed my old version. Okay, in Kubernetes it will be like that because there will be multiple server will be run, right? So if you want to kill properly, the edition should be proper. Okay, that should you have to mention properly. That is bit headache things. Okay, then rollback will be bit slower in the Kubernetes I'm mentioning. Okay, so blue green is nothing but like it's based on the traffic is high or low, or you can able to manage that one. So canary is nothing but how the your API routing going to be happen. That is the things. Okay. So after that, these are the advanced deployment patterns. Is nothing but so first one is a featured flag. Featured flag in the nothing but whenever if you are deploying anything, like if you are introducing a new feature your application, initially while that is in the testing phase, don't move to production actually. So until unless that version was stable, the version also stable, but you are not confident, you can make it as a alpha beta. What is mean by alpha beta? That means that is under testing. It's not a stable version. You can mention that, but it's not a good idea. You can mention that is the future, like this is the new future. There will be some bugs, like how AI was mentioning. This is the AI model. I can do the mistake. I can make mistake, right? So like, so the major things is going to be these are the things: how you are deploying your system, how the rollback going to be, how you are getting the quick response, how you can prevent that. So how you are crash going to prevent until unless if I am doing manual rollback here, right? If I have to click this three dot, I have to click this rollback. Instead of that, you can do the automation also. That is a prevent technique. So every 15 seconds, I have to hit my health API. If it is health API not respond back, so next second what I have to roll back the previous session. So like that, if you, for example, I am telling it will be differ based on your own condition. Okay. So that is the first thing. So another one is the progressive delivery. So this is also another big thing. Circuit breaker. So anyone have the idea about the circuit breaker? This definitely in Java, this guys will ask what is the circuit breaker. Like if it is take an example, my payment service is no longer available. My payment service went down. So that means if a client continuously reinitiating the request to the payment service, what I have to do? How to manage properly. So that means I have to try to get the things from the payment service, because I already know payment service is not working anymore. So I have to handle such a way. So you can try after sometimes like that I have to manage. So how, if your anything is broken, how your circuit breaker? Circuit breaker is nothing but like anything in that phone not available. Like most of the rooms, electricity, if you are taking in your home also, they have some breaker things like that is a kind of example you can take it, but that is for switch. But what that circuit breaker will do, if any mistake, like you are if you are put fingers as any particular things, if it is sharp will be happen, any miscommunication will happen, the breaker automatically down. You can don't test it, okay? If you are don't test it in the home. If you are trying two wires, if you are connecting the finger, if it is definitely the breaker become down. But don't try it. But for example, I am telling you, if any accident case, if it is crashed, the breaker automatically will down. So that means the power will be cut. Same way, the circuit breaker also working in your server. All the example, what are the things we are learning, right? Everything we are taken from the real world work. So how the circuit breaker working for the electricity? Same way, same concept, the circuit breaker available in a server. Now take in the server. In my server, payment service is not working anymore. That means the payment not debited, payment not created at all. Why I have to continuously initiate the request? That means I put my things in the switchboard. If I got the sharp, why I have to continuously kept my finger in that one? I can take from that one, right? So that means no need to initiate the request to that service. Okay, if it is not available, it will not available. So our circuit breaker will do just turn off the electricity by default for power coming for this switchboard, right? The same thing I can do that. Okay, that is circuit breaker. But if guys have some online for that, prepare for that one. Okay. So database migration. So this is a big headache for database migration. Okay. So definitely you are creating your data. Okay. So initially you created the table. Like I take example our student table. So in that table feature you want to add one more new column. Okay. But that column was not null. That means that column no need to contain the null values. Okay. Already my table in my production server I have the 1 million records. Those records until now don't have that column. If I am doing the migration, my server going to run smoothly or it will broke. If it is a document database, it won't broke. Why? Because schema will be apart from the documents. Because documents you can add more data. That is not relay with the schema actually. But the key not available in the schema also you can add the data to the documents. That is not an issue. But in RDS, there is a database management. If you have the database already, that have the million records. Now we are going to introduce the new column as a not null column. How we are going to handle that? If I deployed that, is my server going to run properly or it will crash? What going to happen? What will happen? Okay, if it is crash, why? Better I don't tell anything. I kept it. Because if you are telling answer, I am raising some questions on that, right? Why? Why it will crash? Think simply. In the relational database, you have the everything is linked with the rows and columns. If you are adding the new column, that is a not null column you are mentioning, what will happen? Definitely you are inserting for each record you need a data. Where the data will come? Because those data already have in my table. How can I add the new data to that record? Each record, million record also, how can I add the new data for million records? So either I can remove the not null, I can make it as a null, or else I can keep some default value. These are the two values. So this is called as a migration. Migration is nothing but you are doing the new table changes. How it is smoothly applied in your production tables. Because already user using it, I can crash my server. That's why sometimes like most of the scenario, if you are in the developer lifestyle, like if you are starting, what will majorly going to happen? If you deploy like some things will work in your local system, but you deploy it won't work. That's why most of the companies having the three stages: dev stage, staging, next one is the production. They will test it in the test server or dev server. They will tell. They will test everything in the server first thing. If it is fast, they will move to the staging. Staging is nothing but this is ready to move the production. They will test again in the staging as well. After that only they will move to the production, because if any one of the issue found these two stages, I can fix it. But if it is went to production, like a few days back also, I think last week or before that, I'm using RAG. I think Elon Musk always will do that. What group will telling? I got 500 internal error. They are simply telling actually. They don't care actually, but that is not a good sign. If someone paying some money to you, they are using your services. If you are giving some not proper error as well, like my server was down, can you try server was downtime you are facing? Like I can tell try after some time. That is the way how you are handling the user experience. That is too important. Okay. So that is the migration actually. So okay, fine. So when we have to go to the serverless, so here is a bit confusion part. So I am deploying all the things for the server. What is meant by serverless? Now we have to get the clear idea about the server. Who have the clear idea about the server? What is server? What is meant by serverless? Why? Because these are the few keywords only definitely around with us. Okay, we have to get the clear some idea. So what are those actually? First one is the server and the serverless. What is mean by it?
Which server the website runs based on local host or anything.
No, come again.
Taking example of servers, we'll run our website in local host. Coming to serverless, we'll be adding those images to Docker images and running in a container, Docker container.
Okay. So how it is here where the server and serverless things was coming actually?
So depending on server, we can handle these websites through Docker container. we can start and stop the server to Docker container instead of
If
local.
they have one minute, yeah. This is yeah, correct only. Let me show some examples. Images. If there example not there. Okay. This is a serverful and a serverless. So what is mean by serverful and a serverless is nothing but so whatever the final things your application or your website anything going to serve something. So always this is a server. But this serverful serverless concept when it will come, like how you are deploying your service. That is mean by the serverful and the serverless. Serverful in the sense you have to manage the things like VMs and how they each storage, everything you have to manage, like how the CPU going to be, what is the CPU size, everything we have to do. That means this is serverful. So we have the some set of machine we are taking, we are took the rental from there. Like 1 minute, if I have, I can show that one. Actually, this is the GCP. So this is look like this is how the cloud. So actually here this is visible clearly or not that much clear. Now clear, right? Now these are the instance I have. Okay. So these are the few servers I have. That means these are the each service instance I am showing here, right? Each one has the one of the services. Okay. So that means it's nothing but each one has the one of the machine. How my local laptop was here. So like that, this each things as one of the machines. So in that machine, actually this start from GKE, right? These things is maintained by the Kubernetes. So maybe it will be killed anytime. These are the this is called as a spot VMs. Spot VMs is nothing but is a temporary VM. How the flexibility cloud giving? You think about that. I don't need that much server now, that much storage, that much CPU. I don't want. I can remove that. But in local, once you bought, you can able to remove. You can whenever if you need, can you take the RAM, storage, CPU from the CPU from the shop? You can do that. Not possible. But there here it's possible. Okay. Actually, this is the one of the VM. Like these are the things we have. Actually, it's supposed to be. I don't know. I can show this one. I can. How to create the VM. So once you click the VM, so here I have to choose the name of what is your name. Maybe it's going to be some student management. You can keep it your server name. Okay, so this is full of server full deployment. That means I have to manually configure what is the machine size. Okay, so I didn't show that, right? So this is the machine size actually. So here you have the series as what is the EC, E2, E3. These are the capacity. So E2, N2, this is like a more capacity or lower capacity. How much memory you want. Like as of now, I only choose the medium. I can choose some other things also, micro also. I can choose some smaller unit also. If I am choosing this core, so here only 2 CPU was coming, 1 core, 2 GB RAM. So what is the cost for that? So entirely $13. So 2 CPUs are $12 per month, 10 GB is my backup system. This is going to be $1. Maximum I have to pay the $10 bill. So this is kind of rental. How much you are using, you have to pay for that. So that means I have to manage this VM. So that means I have to manage this machine, right? So this is the stateful services. Stateless services in the sense, I can only give my instruction. You have to deploy this application, that's it. I am giving my image, you have to deploy this application. While I am clicking some particular link, what you get, the application should be available. That is a stateless service. So that means I don't manage this infra. Infra is nothing but what are the VM you are choosing, what are the types of RAM, how much CPU you want. Those things we are choosing now, right? There we won't choose. Everything will take care by the cloud providers. So in GCP, this is a, I think here it is called as a cloud run. Okay, actually this is a cloud run, so you can deploy any services to here. Actually, I can deploy my repository, like that means that my GitHub repo, or else deploy as a container also I can do that. So these are the ways. But here, while I am deploying as a container, if I click the right, I won't select my infrastructure. That means which VM, which size I want. I won't choose those things. I mainly choose what is my image. That's it. So here image URL I have to select, right. So if I clicking, I think these images will coming from. So these images will coming from my artifact registry. So I think I can show fully. Okay, so there is some security. So this is the things I can get my images. Once I got my images from that particular image, I can deploy the things. Okay. So which one you want, which service you want to deploy, I can deploy from there. Okay. So actually these images coming from the artifact registry. So this is the entire cloud actually. So these are the services like a Kubernetes engine, BigQuery we not needed. Are the major things we have to know. This you also use open GCP console. You just take a free trial for 3 months. You don't need to pay zero. Okay, initially you have to give card details, but they won't debit anything, so no issue. So you can choose each services. What is the major purpose? The main thing you have to start from the compute engine. Other things you have to know: compute engine, cloud SQL, IAM. So these are the major things we have to know. IAM is nothing but what are the roles, what are the privileges you are going to give. Like this cloud, I am only not using. My another guys also using. I have to give the privileges. What is the what are the services you can use here? Okay, you can use the compute engine, others you can manage the VM. Everything I can give the access. Okay. So this is the entire cloud platform look like. How does it look like? This is the things actually. The major thing going to be, if you know, I mentioned as artifact registry, right? Yeah. So So the artifact registry is nothing but it contains the all your Docker image. From that image only I am deploying the things. So apart from this, one more things will be important, that is called as the buckets. Buckets is nothing but that is kind of storage system. How you are local, you are managing some folder, right? This folder, like that means if I went any trip, this is the trip one, my photos. This is trip one videos. Like that, this is a steady material. Like that, we are keeping, right? In cloud, you want to keep the files or any data you want to manage it, you can keep it in the buckets. Understood? These are the overall cloud structure going to be. So I hope you guys get some idea how to create the VM. Okay, so you guys try to create the VM. You can go to the GCP console. You try to get the 300 credits for free actually. So no, so many student benefits also there. If you guys have the student ID card, you can get some GitHub Copilot also. 2 years it's free actually. So you have to pay $10 per month. If it is, you have to pay.
Container and bucket difference.
Container bucket is totally different. Bucket is like how you are managing your storage. You are keeping your files, right? Local you are managing. If you have to manage your files in the cloud, there you are going to store. You have to store in the bucket. You can keep the bucket name like how you local folder you are keeping some name, right? This is the steady Java material. This is React material. Like that in the bucket you can keep it. This is my Java material. This is my another React material. You can create the folder. There they are calling different name. That's it. There we are calling as a bucket system. Container is nothing but this is totally different. Container is nothing but like what are the you have to run your own application. Like you build the image. From that image, definitely prerequisite is already you build inside that image, right? While you are make the things as a container, like you can share that image to other guys. They can able to run. They can able to get the same output from that image. That is called as a container. Okay, so now I guess hope I guys got the clear idea about these three things: serverless. Another one is the managed Kubernetes. That's what I showed. Like a few VMs I showed, right? Those things managed by the Kubernetes. I'm not managing anything. I'm not creating any VMs after. That is everything done by the Kubernetes. If my service, like if my load was too low, it will delete the few VMs also. I don't have to pay the bill for those VMs. Okay. Cold start optimization. Okay, fine. So these are the major things. Until now we deployed our application, everything. Here is a monitor. Why monitors is really matters. If your application, if you are not monitoring, your main thing is going to be while you are scaling your system, you don't know when my application is going to broke. What are the places my application got broke? How do I know? We are I am using my application. Anywhere it is broken, I can able to figure it out. But I gave to my application to my clients. Now my clients are using my application. How do I know this particular place was broken in that place while my client was using? So you have to monitor, like that I initially explained with Prometheus and Grafana, right? These are the tools. That are those are the monitoring tools you can able to monitor the system. Each API serving the what is the response time of the each API. Is API is working for good. Is post API how much time taken to give the response? Everything we can track it. So that the major things is going to be the metrics. Metrics is nothing but how much CPU and storage used by that particular service what you deployed. You are deploying some particular product, right? In that product, how much hardware it was using, like how much storage it was taking, how much CPU it was using. Based on that, if you want to reduce or based on that, if you want to increase, also you can do that. So that is we need definitely metrics is too important. Next one is the logs. What is the logs? Any idea about logs? You guys have any idea? What is logs?
Log is something like it stores every instance of my execution.
Come again?
Stores the instance
that is logs. Logs is nothing but like if you are deployed your application, so how you can track those systems. So we have to some tracking tools, monitoring tools we are using, right? There we are, what we going to see, we going to like whenever I run my Java like a Spring Boot application, I can see some commands. Now the servlet was deployed. Now Apache Tomcat server was started. Those are the things is known as logs. Logs is nothing but what is the current state, what the application, your machine, your application was doing some operation, right? Some process. What is the current operation my application was doing? You can able to see that. It is broken also when it was broken. What is the input I am given? Why it was broken? Everything you can get it from the logs itself. Okay. So in the logs also we have the levels, info level, debug level. So these are the error level. These are the levels we have. Debug level we won't use in the production most of the time. Info only we will use. So what is the difference between the each? Info is nothing but what that going to do, what it is complete. That's it. Debug in the sense while I am doing what are the data I used. Like let's say example while I am sign upping. So what info level logs will show. So okay, now new sign up trying to register. It won't tell who is the register email, who is the sign up email. But if you did in the debug level, it will tell what are the input I received, email, username, those things we are receiving, right? Those things I can show. But most of the time, don't log the security related data. That means the password and those things don't log. That is too bad. Okay. So these are the levels I get in the logs. Traces is nothing but while you are looking into your logs, so your application got crashed. Like whenever I am running my Spring Boot application, if it is somewhere it was crashing, I have to go at the top. I have to trace like where that exact error happened, when this error will be happen, how the error will be triggered. This particular place to this particular place, everything I am debugging, right? That is called as trace. That is the things. Okay. Next one is the alerting strategies. So this one actually we already initially discussed. Alerting strategies is nothing but now your VM, I have a VM, right, virtual machine. That VM almost used 90%. That means my load was full. So what I have to do before going to broke my system, I have to increase the storage capacity. I have to increase my capacity of my system, my server, right? So those times you have to return, have to trigger some mail or some other notification. You have to trigger, you have to alert the system, you have to alert the guy who is the responsible. If the Kubernetes is responsible, you have to tell the Kubernetes, okay, I'm out of running memory. You have to give more memory like that. Okay. So like in any car or any bike, they will blink the, if you put fuel not there, they will blinking system was there. It was too low, you have to refill. Like the same system alerting strategies. Like how you are going to alert. Like if a server was good, how much error happening. Like continuously or all the API was failing. That is the error rate. So what is the error rate percentage now? It is a 1. It is the 10%. It is gradually increasing 1 to 10, 15, 20. If it is gradually increasing, that means some errors issue was there. We have to fix it. So we have to trigger some alert system. We can get the issue. We can fix it. Okay. So here we have the alert security levels also. What are the P0 in the sense? We have to fix it immediately as much as possible. Okay. Next one is the P1. That is also more important, but you can take some more time. Compare than P0. But P2 is like okay, fine. My application was working, so it's not any broken changes. That means I can continue the flow. But while I am doing some additional process, it got crashed. Okay, no problem. I can fix it. So that's why they are mentioning P0, P1, P2 like that. P0 is the top level. Whenever if that issue happen, if you are sleeping also, you have to wake, you have to fix it. Okay. So next things like we can deep dive into the Kubernetes concept, because we are mainly doing the system design was completed so far. Okay. Tomorrow what I planned, I will give some requirements. Okay. You guys are designing the system. Let's see. Okay, how the it will look like we'll do some mark kind of things. That will be the real the mark kind of things. We'll do that. Okay. So if I'm giving the requirement, how you guys structuring the system, we'll get some system design things next class. Okay. So system design was completed so far. Okay. So this is entirely one of the things we are discussing. This is the cloud engineering. Okay. So let's deep dive into that. So first one is the parts. So parts is nothing but it's the smallest deployable unit in the Kubernetes. So nothing but you want to deploy one particular payment service, you can deploy using one part. So that is a smaller unit in the deployment process. That is called as a part. Okay. So another one is what are the key points maximum. This is a here each part have the IP. Shared network space, same IP, lifecycle management together, core locator, shared storage volume. Everyone like this saying this is not the thing. Okay. So this is how the YAML file look like. If you are initially configuring one part, you have to specify the version. What is the kind of this service? This is going to be the part service. Okay. So this is how if you are using the Kubernetes, you have to design such a you have to tell the Kubernetes YAML file like that only. YAML file you have to mention like this. What kind of things I am going to do? Now I am going to do for the part. Next one is the metadata. What is this part going to do? This is part going to deploy my payment service, payment app. We can do that. Next is the specification. So specification is nothing but what are the containers it has, like what is the app, what is the reverse proxy, what is the port it going to run, what is the command to run my application. So everything you can define in this YAML file. Okay, this is for the part. So most of the common use cases single container per part. So that means if you are deploying one particular service, you can deploy with the one container, right? So you can use one part, most common. Sidecar container, this is not required. So init container setup before main adapter pattern. So this is not required. Okay. Don't relate unrelated apps in the same part. Okay, that means that if you are using one part, make sure if you are deploying the services inside one part. I am telling most of the time keep it isolated. Each part deploy the one service, that is more advisable. But if you want to deploy two services in the one part, keep it is more similar services like a payment, how it is similar with the other services. If any similar services was there, then only you keep it in the same part. But the most advisable things, don't keep the two services in the single part. Okay. Okay. This is for part. Next one is we have to know the services. Services is nothing but how the stable network like a part I deployed my application. That means my application running in some particular port, some particular IP, right? Now I want to trigger some API. It has to go to that particular part. I have to return some response, right? So here this is called as a service. So how the request mapping will be happened here? So simple. The major things will be DNS naming remains constant, like a load balance across the parts. That means the load balancing mainly this request is going to be this particular part. This service only I have to give this request. So these are the major things for the services. Okay, here we have the few services is called as we have few types. One is the cluster IP, another one is the node code, another is the load balancer and the external names. So what is meant by cluster IP is nothing but that is the internal IP address. Okay, all the things have the internal IP and the public IP. So if you are taking any system, any things like if you are taking my system also, definitely it has the public IP, definitely it has the internal IP. So when can I use the internal IP? So you want the communication between the like this router. I connected all of the guys is connected to the same router. I can use the internal IP. If I want to connect, I can access. If anyone connected this ACT router, I can able to access your system actually. So if while I'm accessing, I can access via internal IP only. I don't access via that router IP because that is used for outside of that router, not inside that router. Okay, that is the actually cluster IP. Another one is a node port. Node port is nothing but node is a smaller unit. That means your application was running. Which port it was running? 8080 or 8090, like that is. If anyone want to access your particular application, like what I earlier explained, like in the Brave browser I am requesting something, how it's finally come to my Brave browser that response. If I am searching like this particular server and serverless request to Google, right? How exactly the response coming to this exact picture, exact page here, not going to other browser, not in another tab. How it is coming the same tab? So everything based on the port, which port it was running. Another one is the load balancer, so no need additional info about it. We already mastered in that load balancer. Another one is the external name. External name is nothing but DNS aliases. Alias is nothing but how we are doing the SQL queries. We are doing some alias names, right? The same thing you can do the some DNS names also you can do that. So this is for the service in the Kubernetes. Next one is the config map. We can see config map is nothing but part of the security, like a secret data you want to keep. You can keep it in the config map. You can look like it's going to be key and value pass. So major I mentioned as environment variables. You need a config any files or any volumes or hot related reload possible or separate config from the code, because most of the time our security related code, like if you have any hashing code, any password, anything you are doing, keep it is most of them in the config map. Okay. So deployment is nothing but this is not one of the type. This is one of the things actually. So deployments is going to be the derived from actually two things. One is the pod, another one is the replica set. So replica sets is nothing but now my payment service was running from the one pod. Okay. Now more request was coming. That pod can't able to handle. But if you are properly set up with the Kubernetes, the Kubernetes automatically create the replica of that same pod. It will manage the another request. Like I have 1,000 requests, the 50 records distributed to the each parts. How you are managing the things. Okay. So that is the deployment process. So secret also more or less same, look like the config map, but is you want to difference between the config map and here, like this is mainly store the your like authentication we did, right, the JW authentication. For that we have some half tiered node. Yeah, that is our secret, right? So for those kind of secret you can keep it here. Config map, what are the things you can keep it like some environment variables, like you can keep it your like a database host, where it will, what is the database name, when it is hosted, like what is the port it was running, everything you can configure in the config map itself. Okay. Once you map anything in the secret, you can able to access what are things you map in the secret, you can access from there as well in the config map. Okay. Next is the increase and service mesh. Service mesh is nothing but like how the service to service communication will happen. So what I mentioned earlier, right? So here in Kubernetes, how the communication will be happen in the Kubernetes. So they can able to, they are using one terminology is called as a service mesh. How the nest was built, the same set of things. Each node is one of the pod. Okay, each service is one pod. You want to communicate between my user service to payment service, like who did that payment, how do I know? So I have to get the things from the my user service. So I can able to trigger. I can use some APIs. So here we can use the service mesh. Okay, so these are the in Docker we are mentioning the images, containers, star services, volumes. Next one is the networking, right? These are the major topics in that. These are the major concept in the Kubernetes. If you know these things clearly, that's it. Like how you have got the clear idea about the Docker, you can get the clear idea about the Kubernetes as well. Stateful state deployment, comparison not required. Okay, fine. So those are the major concepts. The next one is going to be the service discovery. So service discovery is nothing but you you want to like anyone remember like in our dependency injection, like you are resolving some dependencies, right? How the dependencies was resolved actually, because in my Spring container I have the plenty of objects. That means the plenty of beans was there. How it is exactly picking particular bean, particular object, and how it is resolved, how the object got injected. That is the one thing is called as a class path finder. Okay, that means that based on that class name, it will find, okay, this is object belongs to this class, because each things we definitely the Java everything is come under the class. So there is one thing that is called as a class path finder. What it will do, whenever if you are using that class path as a type, it will search in your container that's based on the same class type, it will fetch it. So there we have the class path finder. So that is one of the concept, right? The same thing here we have the service discovery. Like you want to find any one of the services or how what you deploy, you can use the service discovery. Like you can able to do the communication as well. Okay, so I can show some architecture now. So how the service discovery flow going to be. So this is my service discovery. This is one common guy. Okay. Here what I will do whenever I deploy the service, payment service, user service, all the service if I deploy, I will register to my service discovery. So how the service discovery will work? Whenever if any things I am getting from client request, going to my query service, I can going to my service discovery. Service discovery will know I have to pass these things to this particular user service or payment service or service A, like that. So this is the actually service discovery. Okay. So if you want the depth also we will explain, but okay. So today this is fine. Okay, I am stopping here. The stuff things I will continue the next session. Okay. So service discovery mainly focus on this one only. So this is like a few patterns also we have in the service discovery. One is this is the overview, like a client side discovery, server side discovery. So client side discovery is nothing but again. So which page I have to show you. Like if I in this tab, if I am running compute runtime, right? That time only I can able to see this page. So which page you are rendering, which page you are showing, this everything is common. The service registry only. So from client side itself, you can able to show. Like if you are requesting this one, I am going to show this page. That is a client side registry. Service like a server side registry in the sense we deploy the more services, like what I showed initially. This graph, I think both are same only. Yeah, so everything is same only. So how I register that all the services to service discovery, each services. If you want to do any communication between the service, like now I am processing the payment service. Okay, now I have only the user ID, but I need the after done the process payment, I have to send the email to the user. That time I need an email, I need a username, right? So how can I get it? I have to call the things to the user service to another service. That time also I can get the help from the service discovery only. Okay. So these are some things. Okay, today's this is more than enough. Like upcoming sessions, we'll see the rest of the things. What are the service discovery tools we have? What are the other things we have? Everything we'll look into that. But tomorrow is mainly focused on the system design. Okay, system design was completed, but this is the cloud engineering related. So tomorrow what we'll do, I will give some requirement. You guys just to try to create the tables. How many tables we need? When I have to place the API gateway, when I have to place the load balancer, how to deploy in which cloud provider, everything you guys choose, I have to explain why I did, what is the reason, this is the reason, that's it. Okay, clear? Okay, these are the major things. If you have any doubt, ask, or else we can close this session. Any doubts? Everything is clear? Okay, come up with things. Tomorrow we'll test it out. Okay, so I will give the requirement. Based on the requirement, you guys try to activate the system. Okay, my system going to be like this. This is the API flow. How much API I need? How much users it can handle? You guys do some mark, and if you get half an hour maximum, you do some mark. get the things from some AI tools or some other things. You can do the mock interview kind of things. Like I give some requirement, I will design the system. How many APIs I need, what are the tools I have to use, which database I need, based on the requirement only. So maximum you try 1 or 2 requirements. I will give the 1 requirement. You just try to design the system. Then I will get the clear idea what is your understanding in the system design. Okay, based on that, if you want to recall also, we can do that. Okay.